Hello everyone and welcome to yet another exciting video at MLDon. So in this video we're gonna start creating Pytorch dataset classes, right? And what do I mean by that? Regardless of the type of data you have, whether it's about images, video, audio, doesn't matter, text, whatever have you, tabular data for God's sake, whatever. If you're gonna use Pytorch to feed that data into your neural networks, number one thing you have to do is you create a class, right? And you use that class to store your data and to define functionalities that are of interest to you about your data, right? For example, you can create a class to store your data and then different functionalities for shuffling the data, for sampling the data, for, subscripting your data, meaning that, okay, give me the 5th index of my data. So by creating that dataset class, you can add all of those functionalities, right? So number two is after creating that class for your data, you have to make sure that you inherit from Pytorch's abstract dataset class, as you can see in the heading here. So Pytorch has a dataset class already defined for us, and all we need to do is to make sure that we subclass this, right? In other words, we inherit from this. Now, this is what it is. Let's just take a quick look as to what we're looking at and try to understand what it is. Number one, it's just a simple class in Python. The name is dataset, and it is inheriting from the object class. Well, most classes at the end of the day will eventually inherit from the object class in Python, because everything at the end of the day is an object, whether it's a string, float, integer, or a class over here, right? So the other thing that we notice is that there is no constructor, right? So the dunder init, and by dunder init I mean underscore underscore init underscore underscore, which is the constructor of classes in Python, that doesn't exist here. So this means that we need to implement this in the future. The other thing we notice is that there are 3 dunder functions or magical functions that are already defined here, but only defined here, like 2 of them are only defined in terms of, their names and the parameters, and that's it. So you notice that, for example, the get item dunder function, it has not been implemented. So you notice that if we were to call this, we should get some error message saying that not implemented error, right? So meaning that this get item has not been implemented. So the same is sort of for the len functionality, the len dunder function. And the last bit is the add dunder function, right? Now this is where this has already been defined for you, and you notice that there's already a class being used in the definition of this function. I'll briefly talk about this last functionality later on, okay? But the one thing you need to know is that after you inherit your class of your dataset class from this parent dataset, the dataset class, you must override both of these 2. They have not been implemented, and Pytorch asks you to override these 2. Now, getting more into the detail of what these functions mean. So get item is used to retrieve a certain data point living at a certain index of your data, of your data set, while len is used typically to get the length of your data set, right? Now, if you've studied Python thoroughly before, you notice that you know that the dunder functions, these are the ones that get called magically behind the scene, and you get to define what they mean. For example, you've already used these dunder functions before. So for example, if you have a number, right? So let's say my number is, so this is just a simple value, right? So let's just say a equals 1 and b equals 2, right? So then you can print a plus b, right? And it's 3. But you notice that even if I replaced the integers by just you know, with just simple strings, whatever, it's just an example. You notice that if we sum the strings together, we still get some form of definition of summation, right? In this case, it's concatenation. So it seems that this summation behaves differently based on what the operands are, right? What the type of the operands are. So in this case, when there's strings, all of a sudden the summation turns into concatenation because you can't mathematically sum two strings, right? So this is where somewhere in the string object there is a dunder add function that has been defined in such a way that if I pass two strings to it, it will just concatenate them and return the result of the concatenation. Same story here for the Pytorch's you know, abstract dataset class. We get some sort of concatenation functionality to actually concatenate two datasets together, right? And like any other dataset class, we notice that we have the self keyword here, which is the representative of the instance, right? I just want to show you a quick example as to let's create a dataset class and then let's inherit from this just to see what it is, okay? So I'm just going to create a class called, let's call it MRI, just very simple, right? And I'm going to make sure that I will inherit from the dataset class, right? So let me just run this. Okay. So I'm inheriting from the dataset class. I mean, I can put nothing afterwards. It still runs, and I can still create an object of this class, right? So everything is okay, but this object has nothing in it, right? Now, what I want to do now is to define a constructor for this class, right? So if I were to create the constructor init, right? And let's say I pass, I mean, a list of numbers, right? So let's call them scores, right? And whatever the score is, it will be stored in self.scores. Oh, let me just try a different name. I don't have to, but just to avoid any confusion. So what this does is, upon creating an object of this MRI class, it will store, so the constructor awaits some scores, and then it will store those scores in an instance variable called x, right? So let me create a list of numbers, 1, 2, 3, 4, right? So let me run this. So we have now a class that is inheriting from the parent dataset class, and it also has a constructor, right? Remember that when I say we're inheriting from that dataset, this dataset class, by inheriting we already have all of these three functionalities inside this class. Already is there. So whatever object I create from my MRI class will have these functionalities, right? So they're there. Make no mistake, okay? Now, if I run this, what do you think will happen if I want to create an object like this from my dataset class? It throws an error, right? Because it's awaiting the scores. It's awaiting something, right? So the scores over here, right? And I'm not sending anything. So let me send s, which is a list of numbers, right? Great. Now D is an MRI class, is a class named MRI, which is inheriting from the Pytorch's dataset class, and it has an instance variable within it called self.x that has all of these numbers in it, right? Now, let me connect all of this back to these two particular dunder functions, right? So I told you D already is an object of a class that has all of these functionalities, right? So let me show you something. Let's say we want to get access to a certain index, I mean a certain data point in S or in our scores. Let's say now we have a 1, 2, 3, 4, right? So I can prove it to you. So the object is called D. I can access the instance variable X, right? So if I just put D.X, I should get, I should get 1, 2, 3, 4, right? So that proves that that list lives in my object. Now, what if I wanted to have access to a particular index in this data set? By data set, I mean 1, 2, 3, 4 in this list, right? So can I just say, okay, D and then like get, I don't know, like the index, like index 2. So in other words, can I get, so this is the index 0, the index 1, index 2. Can I access the value 3 through using index 2 just like that? Can I just subscript an object of a class just like that? So what happens? What do you think will happen if I did that? First of all, do I get an error? If yes, what kind of an error will I get? Just think for a few seconds. Remember that the getItem dunder function is for subscripting stuff. Is for you to be able to subscript stuff. Every time you subscript any list in Python, there is a getItem dunder function somewhere in the list object that gets called. Okay? So if I run this, I get an error, and in particular, look, it automatically ran the getItem function within my object D, right? And so that's the magical part about it. You notice it just happened. It just called it automatically. But the problem is this error was raised, not implemented error. And here it is, the raised error, right? Not implemented error, meaning that you haven't implemented it. I don't know how to subscribe a class object. What are you talking about? That's what it's saying, right? So let me override the getItem function. By overriding, I mean I simply write it as it is, but I will fill up what I want to be inside of it, right? So it receives the index of the element of interest, right? Whatever it is. So let's say I want you to return self.x, but not the entire self.x, but whatever item that lives at index, whatever the index that I'm interested in, right? So if it's 5, I'm going to put 5 here and then return the item that lives at index 5, right? So let me run this again. So I'm going to run this again. Great. Now again, I create an object of the class. Now let me see whether this makes sense. Voila, right? So what happened? So it automatically, because I'm subscribing it, subscripting it, sorry, or maybe subscribe, I think subscripting it, yeah. This getItem function gets called, and depending on how I've implemented it, the index living, the item living in index 2, let me change, maybe change these numbers to some random values, because I don't want the values and indices to be that similar, right? So let me just do that one more time. So the value living at index 2 is 66, and that's great, right? So now you know that you understand why Pytorch says override these two functions, because now you have the ability, the natural ability that anybody would want to be able to access different elements in your data set. The other reason that you need this getItem function to be overridden for sure is that, as you will see later on, we will use something called a data loader, right? A very famous topic and a very famous object in Pytorch. This data loader will use this inherent getItem functionality of your dataset class to be able to access different data points in your dataset and select them randomly or shuffle them, whatever it is, and grab a subset of them using getItem and feed, and then after it grabs them, we can feed that subset of data into our machine learning algorithm, right? As simple as that. So that is a very important function. You have to override it, right? The other function that you don't have to override, because it's not always necessary, is the len dunder function, right? So what happens if I wanted to see the length of my dataset object? Do you think it's gonna throw an error again or not? So for those of you who said yes, you're right. It throws an error, and see what happened. The len dunder function gets called automatically,
and inside it, this error was raised, not implemented error, right? Because it doesn't know how to you know, measure the length of a class object, right? So again, you have to define it. You have to override it. It's been defined. I should correct myself. It's been defined in the parent class from which we have inherited here, okay? But we haven't mentioned what should be done within that function. Now let me override the len function as well. So let me just go down, override this, and you notice that it doesn't need any particular argument other than the instance itself, right? So we're not going to send anything to it directly. So it's going to return the length of self.x. That's it, right? So let me run this again. So now, again, subscription works. Now, what about the length of d? So we should be able to get the length of, well, length of self.x, which is supposed to be 4, right? Because we have 4 elements. Now, do we get that? Great. So we do get that. That's great, right? Now, the other thing that I promised that I want to show you is this idea of addition, right? I'm just gonna talk about it briefly, very briefly, okay? So this is a functionality that is in Pytorch's parent or abstract dataset class, and this gives you the ability to be able to sum 2 dataset objects together. It's not really used that much. I mean, at least I haven't seen it being used that much, but sometimes you might want to, you know, sort of concatenate your dataset objects together as one giant object, and then you can access all sorts of indices of different parts of this dataset, right? What it will eventually do is, if you create, say, D1 as one object, as the first object of your MRI class, right? So let's call this S1, and let's say I'll create a second data set, but this time I pass S2, and this object is called D2, right? So these are different objects of the same class. So let me just change the numbers just so we have different values. Now, the idea is, if I sum these together, S1 and S2 will sort of coexist in one giant object, right? That's the whole idea. Then you can use your data loader to shuffle this, to you know, subscript and grab access to get access to different elements in the entire data set or not. Typically what people do is people create different data loaders for different parts of their data, and in each data loader they feed in different data set objects, right? So they not never, but I haven't seen this really as a common use of dataset, where the dataset class where people just sum up dataset classes together to have one big giant, you know, dataset object. People typically create different dataset objects, each for a different purpose. For example, one for your training set, one for your validation set, one for your test set, and then they create 3 different data loaders for these, and each data loader is responsible for getting the items of their corresponding dataset class, or shuffling them, or whatever it is that we want to do. I'm going to talk about data loaders later. So that's about it, really. Right, just to give you a quick example. So I can just create 2 different datasets classes. 2 different dataset objects, right? S1 is one dataset, S2 is the second dataset, and I create 2 different dataset objects from my MRI class, right? So if I were to sum these two objects together, remember that is where the add dunder function is going to get called automatically, right? So if I sum these together and say put the result in D as the concatenation of all of them, right? So the reason that sum worked was because this functionality has been defined, okay, inside the parent class, which is the Pytorch's dataset class. Now, just to show you that this is indeed a concatenation of the two. If I just grab the length of D, right? So D now has both of these two, right? So the length should return 1, 2, 3, 4, 8, right? So because we have 2 there, right? And so on and so forth. Now I'm actually curious, if I were to return the first element, what will I get? Okay, good. So it's interesting. So the first element is 4. Now 0, 1, 2, 3, 4. Index 4 should return 400. Yes, there you go. So it has concatenated them together. Now, mind you, there's one teeny tiny bit that I need to warn you about. Because this dunder functions is using another class inside it, that's called concat dataset. You need to make sure that you will import this dataset, otherwise this class. Otherwise, the addition of the two dataset objects will not work. So that is why at the top I have also imported from torch.utils.data. I've imported the concat dataset as well. But anyway, the most important point is that these two need to be overridden. Okay, and that's about it really. So this video was all about introducing the Pytorch's abstract dataset class. Now in the next video, what we're going to do is we will create a custom MRI dataset class, right? So in other words, we will create a class for MRI dataset, and we'll inherit from this dataset class, and then we will overwrite the len and get item functionalities, and then we will add even more functionalities. We'll also create the constructor for that class, because as you see, the parent class has no constructor, right? And from there on, we'll gradually, slowly but surely move our way to understanding the data loaders, and then how data loaders and dataset classes could pair up to help us train a machine learning algorithm. And then we'll move on towards the actual neural network that we're going to be using, which is going to be, just let me give you a peek, a convolutional neural network. Okay, great. So I hope that this has been informative for you. And if you have any questions, just post them in the comment section down below. And if you enjoyed the video, feel free to like the video and subscribe, and also make sure that you'll click on that bell-shaped button so that you'll be notified whenever I upload a new video. Also make sure to follow us on Twitter, LinkedIn, Facebook of ML Down. Thank you so much. Mind yourself. Bye.